The product rule says the derivative of f of x times g sub x, if you're multiplying two functions together, because they're both functions of x, you can't just pull one outside and go, oh, take this and multiply by the derivative of g. It doesn't work that way. It is equal to the first times the derivative of the second plus the second times the derivative of the first. That's called the product rule. That's another one you want to memorize when you're taking the derivative. An example. If I said to you, what's the derivative of x squared plus 3 times 2x minus 5? Now, if somebody gave me that question, me personally, I probably will FOIL this one out, then take the derivative. That'll be the easier way. Because if you FOIL this one out, you will have this. I'll do it both ways. What's that? 2x to the third, right? Negative 5x squared plus 6x minus what? The 15? And what's the derivative of that? 2 times 3? 6x squared. 5 times 2? 10x. What's the derivative of 6x? 6. That's the answer. But I'm going to redo the problem using the product rule and see if I end up with the same answer. In this example, this will be the easier way of doing it. But soon enough, I'm going to make this the power of 5, and that's the power of 7. So you want to know the product rule. So let's do it using the product rule. I'm going to call the first one f, the second one g. So this is method 2, using the product rule. F of x is the first one, which is x squared plus 3. And g sub x is the second one. What's the derivative f? Might as well find everything we need before we start plugging in. What's the derivative x squared plus 3? 2x, yes. What is the derivative of g sub x? 2. And I'll write that equation. It says the answer to that should be f of x times g sub prime of x plus g sub x times f prime of x. By the way, if you reverse them, you're still correct, because you're adding. When you add, it's the same answer. 5 plus 4 is the same as 4 plus 5. So if you write this one first and this one second, that's still okay. What is f of x? X squared plus 3. What is g sub prime? 2. Plus g sub x, which is what? 2x minus 5. What is f prime? 2x. And let's just simplify them and see if you end up with that answer. So that would be 2x squared plus 6. What's 2x times 2x? 4x squared. What's a negative 5 times 2x? Can we collect like terms? 2 and 4, which is what? 6x squared minus 10x plus 6. Is that the same answer? Yep. Which one is easier? Obviously the top one. But again, we're going to make the problem soon enough worse than this. This power is not going to be 1. When the power is 1, this is easier. Sometimes you don't have a choice. You have to use the product rule. Like what? Like the next example I'm thinking about in my head here. The derivative of e to the x times cosine of x. I can't simplify that. So I have e to the x times cosine of x. So I have to use the product rule. I'm going to let the first one be f of x. And the second one, the g, will be the second one, which is what? Cosine of x. Let me take the derivative of them. What's the derivative f of x? E to the x. What's the derivative g sub x? Negative sine of x. So notice I try to find all the four pieces before I go to the equation. I don't want to stop and take the derivative and go back and stop again. Get the answer to them, then go to your equation. It's f of x times g sub prime plus g sub x times f prime. If every time you do a problem like this, you write that equation, I guarantee you by the time you finish the homework, you memorize it. F of x is what? E to the x. G sub prime is what? Negative sine of x. G sub x is what? Cosine of x. F prime is e to the x. I can factor e to the x out if you want to, but it's e to the x. I never like to start with the negative value, so I'll switch them. Nothing wrong with it, I just don't like it, me personally. So it's e to the x cosine of x minus e to the x sine of x. You want to factor e to the x out? You can. Any one of these answers. This will be fine, that will be fine, this will be fine. I'll do another one with the product rule. I'll wait till you finish writing. Everyone's good? F of x equals x to the 7. What was that one? Cosine? Do we have a cosine that one?
Yep.
I'll do sine of x. Plus, let's have fun with it. E to the x, we'll make it 3e to the x, minus 7 cosine of x. Go crazy. First, I'm looking at this. I know the answer to these two. These are straightforward from the previous section. But what about the answer to this one? So let me find the answer to this one first. And once I have that, then I'll add to it these answers. This is x to the 7 times, so I have to use the product rule. I don't like to call it f here and call them f. Maybe I'll call this y. I just noticed that. I hope I didn't call them f in both cases. Because I'm using f for the first one, g for the second. I don't want people to get confused. Which f are you talking about here? There we go. So let me call the first one f. So f of x is what? X to the 7 G sub x is what? Sine of x. What's the derivative of f? Derivative of x to the 7 is what?
7.
Yep, 7x to what power? 6. And g sub x, what's the derivative of sine of x? Cosine x. So the answer to that is the first times the derivative of the second plus the second times the derivative of the first. What's the first here? X to the 7? What is g sub prime? Cosine of x plus sine of x times what? 7x to the 6. That's only for this. Now we're going to add to it the answer to this one. What's the derivative 3e to the x? 3e to the x. Here's the minus. There's the 7. What's the derivative cosine of x? Negative sine of x. And let's clean it just a little bit. X to the 7 cosine x plus 7x to the 6 sine of x plus 3e to the x plus 7 times what? Sine x. So that's our product rule. We use that when you have multiplications. Product, multiplication. The topic for this video was product rule and what? Quotient rule. Quotient means what? Division. You're dividing things. So let's look at that one. It says if you want to take the derivative, and we'll call the top f of x, we'll call the bottom g sub x. It is the bottom times the derivative of the top minus the top times the derivative of the bottom, the whole thing divided by the bottom squared. Not the derivative, but the bottom squared. Huh?
My old teacher gave us like a funny way to remember that. She said low d high, meaning low times the derivative of the high on the numerator.
Yep.
Minus high
D low.
d low all over the square below its primes.
Oh. So low, d high, derivative of the high one,
Yeah.
minus high, d low, derivative of the low one,
Yeah.
divided by
The square below.
the square of the low.
Yeah.
That's what that is. Yep. Get a tattoo with that. Yep, good idea. I'm going to be pushing tattoos on you, all of you today. Notice here, if you switch them, the answer is wrong because you have a minus. So if you write this piece first and this is second, it's going to be minus sign. 4 minus 5 is not the same as 5 minus 4. But when you're adding, 4 plus 5 is the same as 5 plus 4. That's why the product rule, it doesn't really make a difference which one of these you write first. With the quotient rule, it does make a difference which one you write first. Now, one of the questions on section 3.1, the homework, you had a problem like this. And we ask you for the derivative. Well, to find the derivative of that, you got to use either the four-step process or you can use the shortcut now. And if I want to use the shortcut, I'm going to identify the pieces. The top is f, so f of x equals 6. The bottom is equal to what? X squared plus 4. Let's find their derivatives again. What's the derivative of the top? 0. What's the derivative of the bottom?
2x.
2x. Again, the derivative is going to be, we said, what is it, low d high, so the low, which is g sub x, times the derivative of the top, the high, minus high d low, f of x, times the derivative of the bottom, all divided by the square of the bottom, or the low. And if we fill in the blanks in it, we should be in good shape. What's g sub x? X squared plus 4. What's f prime? 0. Minus f of x, which is what? 6. Times g sub prime, which is what? 2x. All of that divided by the bottom squared. And if I clean that, what do we have? Negative 12x over x squared plus 4, the whole thing squared. That's our derivative using the quotient rule.
You keep that at the bottom.
Yes. I will leave it like that. I mean, you can fold it, but most likely they probably leave it like this. So now some of the problems I said you can't do them yet. Now the answer, yes, you can use the shortcut if you think this is a shortcut. I still think this is much easier than using the four-step process. I'll try another one. Y equals 5x minus 2 over x squared plus 1. Find dy dx, find the derivative. I'm going to identify the four pieces first. The four pieces. Okay, what are the four pieces? Well, let's see. F of x, that's the top, which is 5x minus 2. The bottom, g sub x. What's the derivative of that? Derivative of 5x minus 2 is what? 5. The derivative of this is going to be what? 2x. Again, once you have them, the quotient rule says what? It's the bottom times the derivative of the top minus the top times the derivative of the bottom, all divided by g of x squared. So what's dy dx? The bottom, which is what? X squared plus 1 times the top, which is derivative of the top, which is 5, minus the top, which is 5x minus 2 times the derivative of the bottom, which is 2x, all divided by the bottom squared. And just simplify the top, collect like terms, and we should be in business. 5x squared plus 5. That's this part. Now this is a minus here. 2x times 5, that's a negative 10x squared. What's 2x times a negative 2? Is that minus 4x? But there's a minus in the front. That'll make it what? Positive 4x. Collect like terms. 5 minus 10, negative 5x squared plus 4x plus 5. The reason I like to leave the bottom the way it is, in some cases you might be able to factor this, the top, and one of the x squared plus 1 might cancel out. So that's why you want to leave it like this. Because if you do the math, oh, guess what? I have x squared plus 1 on the top. Now let me cancel it with the bottom. And you end up losing one of them. Well, let's try another one. I'm actually building this up.
Can you leave it there just for...
Sure. More caffeine. Come on. It's good for you.
I'm all set, thank you.
You're welcome. Give you a chance to rest your arm there. Okay. What's the derivative? If I came in and says, show me the derivative tangent x. I want you to prove it to me. Show me what the answer is. Now again, some of you took AP calculus in high school, you probably know the answer. But I want you to show me the math, the derivation. Well, tangent, what's a tangent? Sine over cosine. Oh, guess what? We have a fraction. That's what tangent is. And now I can use the quotient rule. Identify the four pieces. F of x, which is the top, the high. G sub x, which is the low. The derivative of the high, or f of x, derivative sine of x, we said is what? Cosine of x. And the derivative of the cosine of x is what? Negative sine of x. Again, what's the derivative? Low times the derivative of the high, d high, minus the high times d low, derivative of the low. I never heard of that before, by the way. So I'm practicing. Over the bottom squared. cosine x times the derivative f. What's the derivative f? Cosine x. Minus f of x, which is sine of x, times the derivative g, which is what? Negative sine of x. Over g sub x, which is cosine of x squared.
Is that cosine of x squared or cosine squared of x? Or is it all the same?
It's the same thing.
Same.
When you write this, that's equivalent to when you write cosine squared x, it's the same as cosine of x, the whole thing squared, not the x squared, but the whole thing squared.
Whole thing.
Yep. If you square just the x, it's not the same. Yep. So this ends up being what? Cosine squared x plus sine squared x, all divided by what? Cosine squared x. We have a trig identity that says cosine squared plus sine squared of any number is always what?
1.
1. And if you want to rewrite that nicely, you can say 1 over cosine of x, the whole thing squared. What's 1 over cosine?
Sine.
Try again. 1 over cosine?
Secant.
Secant. So it's the secant squared x. So the derivative, that's one of the, again, another one to memorize, but there's the math behind it. The derivative tangent x is secant squared x. I'm going to add a few more to that. I'll wait till you finish writing. I'll combine them on one sheet. The last video we said we should know these things. So the derivative of e to the x we said is what? E to the x. Good. The derivative of sine of x is what?
Cosine.
Cosine of x. The derivative of cosine of x is what? Negative sine of x. We just derived the derivative of tangent x. We said the answer is what? Secant squared x. That's the one we just did. The one we just finished. So guess what the derivative of cotangent x is? Similar to this, but instead of secant, it's going to be what? Cosecant with the minus sign. We can derive that if we want to spend some time on it, but that's the answer. It's getting late. You're getting tired. My back is getting tired. The derivative of secant x is secant x tangent x. I can derive that too using the quotient rule. And the derivative of cosecant, it's negative cosecant x cotangent x. This is what we need to memorize. I wrote them this way intentionally. Any trig function that begins with the letter C, the answer is always what? Negative. Every single time. And if you know what sine is, cosine, oh, cosine must be the opposite. If tangent is secant, cotangent is cosecant. So once you get this one, that's really easy to memorize. Oh, I see the pattern. This one, similar to that, instead of secant, tangent, we use what? Cosecant, cotangent. Notice when you have a C for each one here, it has C in both of these. Except that's the only one that's breaking the rule. But when you have a C, cotangent begins with the C, the answer begins with the C. Cosecant, both have C's in them. C, C, and C. So a few pattern, few things to look at. Oh, that's one way to remember them. Whatever works for you. So have a sheet handy like this, and as you do each problem, just write the equation down. By the time you finish, I'm telling you, by next class, you'll know them. I keep writing them down every single time. Let's say I have this problem. What's the derivative of that? The derivative of x is what? 1 minus, what's the derivative of tangent?
Secant squared.
Secant squared x. Let's have you think here. I don't know, I put a space between them, big space. I'm not sure why. Well, I know why I put a space, but I didn't mean it to be that big, because I want you to see it's really a multiplications. And if it's multiplication, what rule you have to use? Product rule. So this is f and that's g. So f of x is the first one. G sub x is the second one. What's the derivative of f? 1. What's the derivative of g? Derivative of secant is secant of x tangent x. Product rule again. It says it's the first times the derivative of the second plus the second times the derivative of the first. That's what the derivative is. What's the first? X. What's the derivative of g? Secant x tangent x. Plus the second, which is what? Secant x times the derivative of the first, which is 1. Again, you can just drop the 1 there. You can say, well, it's x times secant x tangent x plus secant of x, or if you want to factor secant of x out of them, what's left in the first one? X times what? Tangent x plus the 1. Either way. I don't have any preference, and I don't think the software has any preference. So I think we figured out what the product rule, the quotient rule, and one more thing is higher order of derivatives. So you might have a problem. If you're still writing this, I'll wait. We're almost done, actually. Like 2 more minutes. Higher order derivatives. Let's say you have this problem. Y equals x to the 6 plus 5e to the x plus sine of x. I say, what's the derivative? The derivative x to the 6 is what?
6x to the 5th.
6x to the 5th, yes. What's the derivative 5e to the x? 5e to the x, yes, again. And what's the derivative sine of x? Cosine of x. What is the second derivative? That's the derivative of the first derivative, the derivative of this. So what's the derivative of this? 30. X to what power? 4. What's the derivative 5e to the x? What's the derivative cosine of x? Minus sine of x. If I ask for the third derivative, that's the derivative of the second derivative, the derivative of this one. 30 times 4, 120x to what power? 3. 5e to the x. What's the derivative sine of x? Cosine x. Now, if I want to find the fourth derivative, the fifth derivative, I'm not going to put 4 slashes. So what you're going to see him do, go parentheses 4, like this. That's the fourth derivative. What's the fourth derivative? Derivative of this one, 120 times 3, 360x squared, plus 5e to the x. Derivative cosine is what? Minus sine. So minus, a minus sign will make it what? Plus sine of x. I'll do one more. What's the fifth derivative? 720x plus 5e to the x plus the derivative sine, which is cosine of x. But I think you get the idea. You can get a derivative of the derivative. It's called higher order derivative, finding the second derivative, the third derivative, the fourth derivative. What we're interested in Calc 1 is the first and second derivative. They tell us a lot of stuff. You won't see that. You won't see that till we get to chapter 4, application of the first and second derivative. What do they tell us? And that's when you get to see it. Okay, so 2 homework assignments will be open. And that'll be 3-3 and 3-2. Let me snap.